Now I want to go over some examples from chapter 2.2. There won't be the exact same problems as in your homework, but you should be able to get an idea of what we're doing. The histogram, so this is a histogram to the right, represents the weights. So notice the weights are here. We could call this the x-axis, but it's on the bottom, of members of a certain high school math team. What is the class width? Basically, what you want to do is the width of the class is from here to here. We're going to subtract 125 minus, which is right here, 105, which is 20. Our width is 20. You could do that to any two. We have here 145 and 165, and that's also 20. If I want to know what the class width is, it is 20. I'll type 20 in here and hit check answer. Okay. And it says, what are the approximate lower and upper class limits of the first class? My first class is this one right here. The lower limit of the first class is 105. We can see that pretty simply. But the upper limit is not 125. 125 starts the next class. The upper limit would be 124. And that's basically all we're looking for. Let me explain a little about this histogram as well while we're here. On this high school math team, there are 3 people, because this is going up to 3, that weigh between 105 and 124 pounds. There is nobody that weighs between 105 and 144, because I don't have a bar here. Then between 145 and 164, we go up and we see that that's 4 people, and so on. And that's basically how you read the histogram. The table shows the magnitude of the earthquakes that have occurred in the past 10 years. So these are the magnitudes. These are the frequencies. Use the frequency distribution to construct a histogram. I can click here and I can open, see that little box right there? I'm going to open it in StatCrunch. We will be using StatCrunch. And if I click on that, I'll get these values. Now, we can't really create a histogram, so to speak, from this, but we can graph it as a bar plot with summary. Categories in, and the category is earthquake magnitude. My counts are in frequency. And that's pretty much all I need to do, and then hit compute. And notice now we have a histogram. And I can see, well, this is definitely not it, because it starts out at 12, and then it goes up to 14, and then it goes down. And this, as you can see, goes up, up, up. This keeps going up. A and C just keep going up, which doesn't match the way my histogram works. This definitely doesn't look like it. It does look a lot like this one. Here, basically what we have is, it looks like about 12, and then it goes up to just under 15, and then it comes down, down, and down. D would be my correct answer. If I didn't want to do the histogram with StatCrunch, I just wanted to show you how to use StatCrunch. But if I didn't want to do it with StatCrunch, I could just look here and I could see the same information. It starts at 12, so we have 12 as the first number, which eliminates A. It eliminates C. I would say B and D are still in the running. Same when it goes to 14. So the next one would be 14, and these look about like 14, between 6 and 7. Now, between 7 and 7.9, this one looks like it's up around the same 12, whereas this one dropped below 10, which is all I really need to know. And I can see that it is D. You can also make it bigger by hitting this, which might make it a little easier to see what the values are. You can hit this and it gives you something completely outside where you can move this around. And now it really looks a lot like D, right? So basically that's one way you can use StatCrunch. So let's check our answer. Perfect. And now it's going to ask us the histogram. Well, if it's D, it has a longer right tail because you see it's longer going to the right. So the distribution of the data is skewed to the right. Here we have data. Here's our digit and here's our frequency. The last digit of the heights of 42 statistics students were obtained as part of an experiment conducted for a class. Use the following frequency distribution to construct a histogram. Okay, so we're going to first construct the histogram. And we can look at the frequencies and we see they're mostly 4, 5, 3, 5, 4, 5, 3, 4. A goes up to 6. B goes up to 12, but it looks like the highest, it looks like it's up around, we have 1, 2, 3. 3 bars. This would have to be 12 divided by 3. This would be 4. This would be 8. And the top number would be 12. Anything that's going up to 8, which this one looks like, B looks like it could be going up to 8. D looks like it's going above 8. So we can really eliminate B and D, which makes more sense, A and C, because the top number is 6. And none of them have 6. We have 0 goes to 4. Okay, they both look about the same for 0 and 1. And those 2 4s, these look like 4 right here. And there's 2 in a row. This looks like 4, so there's 2 in a row. The next one we have 2 5s. Let's say that's 5. Those are at the same height. Uh-oh. If this is 5, then this is back to 4. I can eliminate C and basically choose A. Okay. Are the data reported or measured? Well, how would we find out if it's reported or measured? The data, the last digit of the heights of 42 statistics students were obtained as part of an experiment conducted for a class. That means we must have measured every person in the class. The data does appear to be measured. The heights occur with roughly the same frequency. That's pretty good. Let's continue on. The data appears to be reported. No, it doesn't look like anybody reported to us. It looks like we measured it. We can eliminate B and D. We are measuring them, we're not reporting them. And then for C, the data appears to be measured. Certain heights occur with a disproportionate number of times. Well, they really seem about the same. They're going 3, 4, 5, 3, 4, 5. They're not that much difference between these values. I'm going to stick with A. If I had one that, like, if 3 was 15, say, for example, then I would say certain heights occur with a disproportionate number of times, but they're roughly the same frequency. So I'm going to pick A and I'm going to check my answer. I do want to show you one more thing. Tornadoes. Let's see what's in tornadoes. What information they're going to give us. These are Excel spreadsheets. So let's download this. You won't have to do this. This is just as more of an example of me showing you something, okay? Let's see how weight is distributed. I'm going to copy the weight, and I can come down here and I can hit get more help, and I Now you can't do this on a test or a quiz because it won't be there. When you're taking a test or a quiz and you want to use StatCrunch, what you want to do is you want to find a problem where that has that little box. This one has that box. I can open StatCrunch up from here, and then I can leave it open. That way, I'm always going to have StatCrunch available. Let's say I have a problem that doesn't have StatCrunch available, but I do want to use it. I can get more help and go to StatCrunch. This is not going to be available on your test. I'm sorry. Once you open it, you leave it open. All I did is I pasted the weights that we just had from that spreadsheet. I pasted in here. And I'm going to go to graph, and I'm going to create a histogram. And my column is weight. Oh, let's say the smallest is, it looks like about 50 pounds. I don't see anything small in the 40s. Oh, yeah, I see something in the 40s. Do I see anything in the 30s? I don't see anything in the 30s. Let's make our start 40, and we can make our width 20. We can even put the mean and the median in there if we want. And I think that's about it. Let's hit compute. Here, when I compute this, this is what my histogram looks like. I can also change my histogram's bin width to 10. And it's going to look similar, but it's going to be more defined. Now we know there's 7 people that weigh between 40 and 50. There's 30 people that weigh between 50 and 60. Now that was really hard to do. It was hard even for us to find our smallest value here, wasn't it? It's in a nice picture. I can see basically how things are distributed. And also, because the mean and the median are very, very close together, 80.5, and the mean is 81.6. They're very close together. That means this is mostly symmetrical. We would call this a normalized curve because the mean and the median, if you remember from the lecture, the mean and the median are almost the same. We could say this is a normally distributed histogram.